Space has long been a popular theme in science fiction, electrifying viewers with its mysteries. However, it's no news that Hollywood often takes lots of artistic liberties, especially regarding outer space. From the dramatization of planetary gravity to the portrayal of explosions in space and misleading imagery of asteroids. Today, we'll debunk 5 popular misconceptions about space we believe because of movies. Number 5. A human body will freeze or explode in space. The concept of landing in space without a suit is often portrayed in films, with varying degrees of accuracy. Take, for instance, the scene from Total Recall where the character's eyeballs burst out of their head, or Mission to Mars where the individual instantaneously freezes. However, the reality is different. In space, there is no atmosphere, which means heat transfer occurs differently than on Earth. On our planet, we experience temperature primarily through convection or conduction, where heat is transferred through gases like air or solid objects. In space, the primary temperature you'll experience is thermal radiation from nearby stars. This means that if you're unfortunate enough to be without a spacesuit, you might feel cold in the shadow of a planet or hot in the direct line of sight of a star. However, these temperature reactions would not be dramatic or instant. The notion of violent decompression in a vacuum, as depicted in Total Recall, is also a myth. The human body is capable of handling a pressure differential of 1 atmosphere, which is equivalent to diving 10 meters underwater. Scuba divers don't suddenly get crushed, and neither would you in outer space. Instead, the air in your lungs would rapidly expand into your chest cavity, causing ruptures. However, if you exhale quickly enough, you might be okay, at least until the liquid in your body starts to turn into vapor due to ebullition. Ebullition is a rather horrific process that occurs when air pressure drops too low, causing the boiling point of liquids to decrease to room temperature. This is why it's often said that your blood boils in space, but it's not due to temperature changes. The longer ebullition is allowed to occur, the more destructive it becomes, causing swelling, bruising, and the formation of gas bubbles in the bloodstream. While this is certainly a horrific scenario, it's not instantly fatal. The real reason you die in outer space is due to asphyxiation. It would take around a minute for deoxygenated blood to reach your brain, after which you'd pass out and eventually die. If someone were to come and rescue you, they'd have about 1.5 minutes to 2 minutes to act. The good news is that depending on how long you entered the vacuum, you might recover without any serious injuries. Number 4. Sound doesn't exist in a vacuum. So, you know how in movies you always hear the roar of spacecraft engines and high-pitched gunfire in space? Well, I'm afraid that's just not how it works. In reality, space is basically silent, and the sound depicted in movies is purely fictional, as sound waves cannot propagate in the vacuum of space. Sound waves rely on the vibration of molecules, primarily through the medium of air. When air molecules are disrupted, they collide with one another, creating a chain reaction that generates a wave pattern, which our ears detect as sound. This process occurs at the speed of sound, approximately 343 meters per second. A visual representation of this phenomenon can be seen when throwing a rock into a pond, where the water ripples accurately depict the movement of sound waves. However, in the vacuum of space, there are no molecules to transmit sound waves, making it impossible for us to hear anything. While it's true that space is not a complete void, with rare particles like gas and dust floating around, these particles are insufficient to transmit sound waves. Interestingly, scientists have realized that technically, all molecules can act as a medium for sound, including the original vibrating object itself. For instance, if an anvil were struck with a hammer in outer space, the ringing anvil would indeed produce sound waves, but they would not be transferred to adjacent molecules, as there would be none present. This raises an interesting question. If a tree falls in the woods and no one is around to hear it, does it make a sound? The answer is no, as sound only exists by definition if there are eardrums to sense the molecular fluctuations. Therefore, the sounds we've come to associate with space travel, such as those depicted in movies like The Martian and Moon, are purely fictional and aren't anywhere close to reality. With that in mind, let's jump to the next myth you probably have seen in your favorite space movies. Number 3. Explosions in space. Now that we understand that the vacuum of space is soundless, it's easy to see that movie explosions are inherently unrealistic. In fact, the inaccurate sound effects are just one of many mistakes that mar Hollywood's depiction of space-based explosions. The first question to consider is whether explosions can even occur in space, given that there's no air. Surprisingly, certain types of explosions can happen in a vacuum, specifically those caused by high explosives. At their core, all explosions involve the rapid release of potential energy. While this release typically results in a boom, not all explosions occur in the same way. For example, the burning of black powder in pyrotechnic compositions is called deflagration, which involves the rapid consecutive burning of fuel. High explosives such as TNT and C4 detonate rather than deflagrate. Detonation is characterized by the explosive material releasing all its energy instantaneously via a shock wave. These shock waves travel faster than the speed of sound, propagating through the atmosphere and solids in a manner similar to sound waves. However, like sound waves, shock waves do not travel well in a vacuum. As a result, an explosion in space would be soundless and would have no medium to propagate through, creating an effect far less dramatic than the flaming, large-scale explosions often depicted in movies. Nonetheless, high explosives can still be destructive in a vacuum, with the energy transfer limited to directly adjacent materials such as the spacecraft where the C4 is detonated. This means that the spacecraft would still be torn to shreds, and the resulting debris would turn into deadly shards of shrapnel. On Earth, flying bits of debris or shrapnel tend to quickly land back on the ground due to air resistance. In space, however, there is no air resistance to slow down the shrapnel, allowing it to travel virtually indefinitely until it collides with another object. This means that an explosion seen from hundreds or even thousands of kilometers away could still pose a lethal threat, albeit after a delay of hours, days, or even weeks as the shrapnel continues its journey through space. If the shrapnel eventually strikes your spaceship, you would want to be wearing a spacesuit to avoid the deadly effects of exposure to the vacuum of space, which can cause your blood to boil. Unfortunately, the dramatic explosions seen in movies like Star Wars do not reflect the reality of how explosions would actually behave in the vacuum of outer space. Hey guys, just a moment before we continue, be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. Number 2. The sun is a burning fiery ball. Stars, as often depicted in Hollywood movies, are portrayed as massive fiery balls in space. However, this portrayal isn't entirely accurate. Stars are not actually burning in a way a piece of paper burns, nor are they mostly yellow as commonly believed. To fully grasp what stars really are, let's break down the complexities right away. Stars begin their journey in clouds of mostly hydrogen gas and dust particles, known as nebulas. These clouds can be influenced by the gravity of nearby planets or simply natural oscillations within the cloud itself, causing the dust and gas particles to clump together. When these particles reach a critical mass, they collapse into a dense point, creating a mass large enough to generate its own gravity. This process, known as accretion, pulls in more dust and gas, gradually forming a star. During accretion, several interesting phenomena can occur. Multiple protostars and protoplanets may form depending on the conditions. The key event in this process is when a protostar accumulates enough gas and dust, creating immense pressure and heat at its core, triggering nuclear fusion. At this point, the mass goes nova. Nuclear fusion is the process where atoms are forced together under immense pressure, fusing to create a new atom. In stars, hydrogen atoms fuse to create helium, releasing excess energy in the process. This fusion generates heat and radiation, making a star hot and bright. There's also a concept known as cold fusion, a hypothetical version of nuclear fusion that could occur at room temperature rather than the millions of degrees needed inside a star. It's worth pausing to note how misguided some sci-fi portrayals are, such as in Star Trek Into Darkness, where cold fusion is used to freeze a volcano into ice, a clear departure from scientific reality. Now, let's delve into the color of stars. The color of stars is often debated and can vary depending on the observer's perspective. According to NASA, a star's color is determined by its temperature. For instance, our sun appears yellow during sunrise and sunset, and somewhat bluish during peak hours. However, these perceived color variations are largely due to interference from Earth's atmosphere. In reality, when viewed without atmospheric distortion, stars appear white or intensely bright white, depending on their proximity. This intense brightness is why the windows on the International Space Station, the ISS, are filtered and equipped with shutters. These precautions prevent astronauts from becoming partially blind or overly suntanned from the sun's intense rays. Additionally, the shutters protect against impacts from potentially dangerous space debris. Stars are not the simple fiery orbs often depicted in movies. Their true colors are often masked by atmospheric interference, and their intense brightness requires significant protection for those observing them from space. Understanding these complexities gives us a deeper appreciation of the fascinating phenomena that stars truly are. Number 1. Flying through an asteroid belt is dangerous. Hollywood thrives on dramatic plot twists and suspenseful scenarios, and space movies are no exception. The depiction of asteroid belts in these films is particularly captivating, often featuring terrifying asteroids and flashy laser battles. However, the reality of asteroid belts is quite different from the thrilling portrayals on screen. In reality, asteroid belts are far less intimidating when you consider their actual size and spacing. For instance, the objects in an asteroid belt are typically about 1 million kilometers apart. To put that in perspective, the Moon is around 384,000 kilometers from Earth, less than a quarter of the average distance between asteroids in a belt. So if you were traveling through an asteroid belt, you'd likely be safe unless you were extraordinarily unlucky. Asteroid belts form for various reasons, often as remnants of cosmic events from the distant past. For example, our own asteroid belt located between Mars and Jupiter came into being when Jupiter's gravity disrupted the formation of nearby planets. This interference caused partially formed planetesimals to collide and shatter. Most of the mass was lost, but some of the debris remained in our solar system, forming what we now call the main asteroid belt. The danger from asteroids is not so much about crashing into them, but more about the potential for collisions with Earth, which is a much rarer occurrence. This concern has been well understood for a long time. For instance, the Voyager spacecraft, launched in 1977, was designed to study distant planets like Jupiter and Mars. Voyager 1 and Voyager 2, which have provided invaluable data about the solar system, including the discovery of active volcanoes on Jupiter's moon, were not at risk of colliding with asteroids as they passed through the belt. Voyager 1 left the solar system in August of 2012, followed by Voyager 2 in November of 2018, making them the furthest human-made objects from Earth. Voyager 1 stopped sending useful data in November 2023, but Voyager 2 continues to communicate with Earth. While Hollywood filmmakers are aware of these scientific facts, their primary goal is entertainment rather than accuracy. Films often prioritize visual excitement and dramatic tension over scientific realism. However, there are exceptions. For example, A Space Odyssey is known for its more realistic portrayal of space. When it comes to outer space, the reality is that the nearly uncharted expanse beyond Earth is a complex realm to portray accurately. Since most Hollywood writers lack advanced scientific degrees, outer space in movies often leans more toward fiction than fact. This isn't to say that filmmakers aren't making an effort. Rather, the intricacies of true outer space are often more challenging to depict than the wildest fantasy scenarios. Are there any ridiculous space scenes you've seen in the movies? What other space myth do you find unrealistic? Feel free to leave your answers in the comments below. If you liked the video, then you should check out the one on your screen. This video on the science of interstellar will blow your mind. Thanks for watching.